Number 70. We have congruent semicircles. They have a radius of 0.326 and the distance between the centers is 0.403. We just have to find this hatched area. So this is a pretty tricky problem. It is a number 70, back when number 70 used to be a geometry problem. So I'm going to change this a little bit. I'm going to make these congruent semicircles. I'm going to make them congruent circles. So I'm just going to extend. I'm just going to extend them. And these are not perfect circles, but I'm doing my best. So here we go. And then what they're asking for in the problem is this area right here. And this cuts it directly in half. We know that because these are semicircles. And so this right here must be directly in between. So this area and this area would be exactly the same. So what I'm going to do is instead of cutting it in half that way, I'm going to cut it in half. Ooh, didn't mean to do that. I'm going to cut it in half the other way. So I'm going to cut it in half like this instead. So I'm going to be finding this area now. And this is an area we know how to find. This is the area of a segment of a circle. So the way you find this area is, well, first of all, let's draw what we know. We know that the radius of one of these circles is 0.326. We know that just from the problem. So that's 0.326, and this is 0.326. I don't need to write it twice, though. Those both are equal because they're both radii. And then what else do we know? Well, we know the distance between the centers of the circles is 0.403. So the distance between here and here is 0.403. And so therefore this distance right here, from here to here, would be half of that, which 0.403 over 2 would be 0.2015. And so this gives us pretty much everything we need to solve this problem. We're going to use the formula for area of a segment of a circle, and that is a sub s equals 1/2 times the radius squared times the inscribed angle, times the central angle, so this angle right here, minus the sine of that angle. So area of a segment is 1/2 r squared times theta minus sine theta. And this is all in radians, by the way. This is all in radians. So we already have most of these values, or we have half of them at least. We know the radius already is 0.326. We just need to find this value right here, the value of the angle. And that's pretty straightforward. We can find half the angle. So we can find theta over 2 by just using trig ratios. We know this is going to be a right angle. And so we could say that the cosine of theta over 2, remember cosine is adjacent over hypotenuse, so the adjacent side is 0.2015, and then divided by the hypotenuse, that's 0.326, and so then theta would be the inverse cosine of this ratio, and then multiplied by 2. So let's see what that is. So 0.2015 divided by 0.326, and then we'll take the inverse cosine of that, and then multiply by 2. And that'll tell us theta. So theta is about 1.81. So I'm going to save this. Let's see. Theta is 1.089. It is 1.089. And I'll use the exact value later. But now all we have to do is just plug into this equation. So we know theta, we know the radius is 0.326. So let's see. 1/2 times 0.326 squared times theta minus the sine of theta. All right, make sure you're in radians, and you get an area of 0.0445. So our area, or our answer, is going to be 0.0445. All right, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.